Okay, let's continue where we left off. I had to pull up draw the picture completely again. So that's why it looks a little different. Let's graph from the beginning. X is 1, Y is 0 here. 10 way out here somewhere, remember, up 1 about here. If I were to go to 100, it would go up Y equals 2, and so forth and so on. So this is going to continue to increase, slowly, but it will increase. Here, going in the other direction, if x is 1 over 10, well, 1 over 10 is just between 0 and 1. 1 over 10 is less than a half, so over here somewhere. So 110 comma negative 1, about. Rough estimate, probably way off. 1 over 100, a little closer. Okay, and then we just sketch it. This is what my graph would look like. Okay, not drawing the scale, but now you have a picture of what it looks like instead of just placing it in Advanced Grapher. But here's what it looks like in Advanced Grapher. There's your function, which is y equals log of x. This is how you type it in, lg parentheses x, close parentheses, in Advanced Grapher. Let's look at an example. Okay, let's look at this function. Let's look at our convenience points, which is basically the basics. There's four or five basics you could do, but let's look at those. Let's look at log base 5 of my first convenience point I like to call. Let's start with 5. Since I have a base of 5, log of 5, you're saying 5 to what power is 5? Well, that's simply 1. Let's look at another one. Let's say convenience points, they're just easy. Okay, log of 1, 5 to what power is 1? It's going to be 0. For any log of any base of 1 is simply going to always be 0. So this one's going to be your convenience point. Here, let's look at log of, I'm going to write the reciprocal of the base. And this is something that you should remember. This is really 5 to what power is 1 over 5? It's going to be negative 1. Why? 5 to the negative 1 power, the rule, 1 over 5 to the 1. Well, there's your rule here. That's why this is negative 1. So remember, if you have the reciprocal, if you have a log function, it's just going to be negative 1. Notice what I have here. Log base 5, watch this, the reciprocal, and then squared. I'm going to write that as 5 squared. Isn't that 25? So that's really 1 over 25. That's going to be 5 to the negative 2 power is equal to 1 over 5 squared, which would be 25. So this one is negative 2. And this is good enough for what we're doing. Let's just sketch it. Well, first let's write out our xy points. We have them here, but let's write them out here just so we can see it better. X was, well, we kind of have it here. We have some of the information here to do this. Let's see, but here we have an expression, x plus 5. I want this to equal 5. So what am I saying? I'm saying x plus 5, or what plus 5 is equal to 5? Well, that one's easy. X is equal to 0. And then y will be 1. Well, the next one, I'm saying what plus 5 is equal to 1. Well, that was easy. You can just go subtract 5 on both sides, or you'll know that negative 4. You could have done that in your head. So that was negative 4 is equal to 0. Now let's do the next one. X plus 5 is equal to 1 over 5. Again, you could do this in your head, or you could subtract. You could go 1/5 minus 5, which will give you negative 4 and 4/5.